Okay, so you just should have completed activity 3 and you should be ready for a conclusion/consensus. They're going to be the same for this activity. So again, the questions that we're trying to answer are, what are the conducting parts of the socket? What are the conducting parts of the bulb? And then what is the conducting path through the bulb itself? So hopefully you were able to come up with that the conducting parts through the socket are all of the metal pieces. So in the case of the socket, the metal pieces are the clips and the plates, which means that the insulating parts of the socket are the base part. So that blue part on the bottom is the insulating part. For the bulb, hopefully you were able to come to the conclusion that the conducting parts are the threaded section, the tip, the supporting wires, which are again the wires that come up into the glass part, and the filament, which you weren't really able to test, but the filament is the little wire that's connecting the two support wires in the picture on your sheet. So that also is a conductor. So those are our conductors for the socket and for the bulb. Now, when you did investigations 11, 12, 13, and 14 with the broken bulbs, you should have come to some conclusion, or at least thought about, what is the conducting path through the bulb. So what you should have seen, hopefully, is that when you connected one of the supporting wires to the tip, that you should have had one of that situation light up. So that would be either 11 or 12. One of them should have lit up, the other one shouldn't have. And with 13 and 14, when you connected the threads to one of the support wires, one of those should have caused the bulbs to light up as well. So that gives us a little bit of information as to what the conducting path is through the bulb. So if we're thinking about that, we know that at least one of the support wires has to somehow be connected to the tip of the light bulb. So I'm going to show that in red. So we know that somehow we have to have the tip connected to one of our support wires. I'm just going to choose this one. And then we know that we have to have some sort of connection between the support wires. That's going to be the filament. And then we're going to go down the other support wire. And since it didn't work to have our parts touching the support wire and the tip, and support wire and tip, we know that this can't connect back down to the tip, but in fact it just connects to the threaded section and then leaves the bulb. So the conducting path through our bulb has to be either through the threads, up the support wire, across the filament, down the other support wire, and out the tip, or it can go in the other direction. It can go through the tip, up through the support wire, across the filament, down through the other support wire, and then out through this threaded section of the bulb. So that gives us an indication of the flow through the light bulb. So hopefully that makes sense in terms of your results for specifically 11, 12, 13, and 14. Okay, which leads us to kind of thinking about some new terms. And the new terms that we have for this activity are one that we're going to be hearing a lot, which is continuous conducting path. And we're going to abbreviate that CCP. And a continuous conducting path is going to be an unbroken set of connections made entirely of conducting materials. Okay, so again, continuous conducting path is an unbroken set of connections made entirely of conducting materials. So that's our first term that we are concerned with. And the second term that we are learning from this is a circuit. And we're going to define a circuit as a continuous conducting path that has a battery attached. Okay, so that is a continuous conducting path with a battery, and that makes it be a circuit. Okay, so that is activity 3. Hopefully that activity made some sense for you and that you're kind of understanding how the bulb works and how the socket works. What I want you to kind of think about in conclusion to this activity is when we put a bulb into a socket, why does that allow us to have a continuous conducting path? So take a look at the bulb in the socket really carefully, especially the ones where the bulb is actually in the socket, and see how that bulb actually helps the socket make a continuous conducting path, especially in light of what we learned about what the path is through the bulb. So knowing that you have to have the side and the tip in contact with some other conducting materials. Okay? So once you've kind of taken a look at that, you're finished with activity 3 and you're ready to move on to activity 4.